Large language models often absorb harmful or sensitive information during training. To fix this, researchers use machine unlearning to remove undesirable content. However, current unlearning methods face a major challenge. They often delete entire concepts wholesale. For example, if you try to make a model forget how to write cyber exploits, it might also forget how to defend against them. True safety requires context-sensitive unlearning, where a model selectively suppresses harmful applications of a concept while preserving its benign, educational, or industrial uses. To understand why current unlearning fails, we must look at how existing benchmarks are constructed. Typically, they split data into disjoint forget and retain sets composed of independent facts. Evaluation then measures isolated factual recall. This approach fails to capture whether unlearning preserves context-dependent use of a concept. If a benchmark only tests whether a specific fact is erased, it cannot verify if the model can still safely apply the underlying concept in a benign context. The core breakthrough of this research is the introduction of dual-use concepts. These are high-level capabilities that can be applied in both harmful and benign contexts, depending on intent and framing. For instance, knowledge of cryptography can be used to secure user data or to build ransomware. By focusing on dual-use concepts, the researchers shift the unlearning objective from simple fact deletion to intent-sensitive concept control. To evaluate this capability, the authors developed ConceptGuard. Unlike previous benchmarks like TOEFL or WMDP, ConceptGuard constructs complementary forget and retain sets over the exact same concepts. The dataset contains over 5,000 instances across 68 dual-use concepts, including cybersecurity, social engineering, and disinformation. Each harmful instance in the forget set is explicitly paired with a benign counterpart in the retain set, ensuring stylistic and structural consistency. ConceptGuard introduces a new metric called contextual separation. This metric quantifies how well a model differentiates between harmful and benign uses of the same concept. It is calculated by taking the model's helpfulness score on benign queries and subtracting its harmfulness score on unsafe queries. A higher contextual separation score indicates that the model has successfully suppressed harmful behaviors while fully preserving benign utility within the same conceptual domain. The researchers evaluated several state-of-the-art unlearning methods on ConceptGuard, including gradient ascent, SIMNPO, representation misdirection, and undeal. These methods were tested on instruction-tuned models like Qwen and Llama. The goal was to see if these algorithms could selectively unlearn the harmful instances of the dual-use concepts while retaining the benign ones. The experimental results reveal a strong trade-off between forgetting and utility. While gradient ascent achieves the strongest forgetting, it causes severe utility degradation and internal model collapse. On the other hand, preference-based methods like SIMNPO and representation-level methods like RMU provide a more balanced trade-off. However, even the best methods achieve only partial contextual separation, showing that current techniques struggle to handle conceptual overlap. A key finding is that unlearning performance is highly inconsistent across different concepts. Concepts grounded in human behavior, such as anonymity and social media, exhibit high variance across methods and are inherently harder to unlearn uniformly. While SIMNPO performs better on intent-driven behaviors, RMU shows stronger separation on system-level concepts like automation. This highlights a lack of fine-grained control at the concept level. While ConceptGuard provides a vital step forward, it has some limitations. The current dataset maintains a fixed distribution of concept frequencies, and future work is needed to explore different thematic groupings and granularities. Additionally, extending the benchmark to more diverse domains and languages is crucial. Most importantly, there is an urgent need to develop new unlearning algorithms that explicitly optimize for contextual separation rather than treating forgetting and retention as independent tasks. In conclusion, ConceptGuard exposes a critical gap in how we evaluate and train safe language models. By shifting the focus from simple fact deletion to context-sensitive concept control, this benchmark challenges the AI community to build more robust, intent-aware unlearning methods. Achieving true contextual separation will be key to deploying safer, highly capable LLMs in real-world applications.